Hi, today we are gonna take a look on that thing. This is a part of an Iranian Shahed 136 kamikaze drone. It is called also Geranium 2 in Russia. There is here the servo itself. Okay, it is connected to that military connector. I have also the second part of the connector. There is a part of the body of the drone. It is a honeycomb structure, as you can see. And on the other side, there is this transmitting rod. Okay, so this thing cannot move. It is maybe due to the gear train inside, or maybe this thing is stuck, I don't know. I paid this complete stuff €1 exactly. The price is quite incredible because even in Ukraine you can find the servo itself for something like €10. I didn't find the function of each wire here. What we can do first is to remove the servo motor from the body, and after we can take apart this motor to see what is inside, and after it will be maybe possible to get it work if the servo motor is not totally dead. Okay, so this is the servo motor itself. And this is the lever and the transmitting rod. Okay, so we can see a small PCB here. Okay, we can see the motor here. And I think we have the potentiometer here. Okay, we can see here the electronic board. Okay, so we can see that we have 6 MOSFET transistors here. We can see the motor. There is a small connector with 6 wires, and there are 2 other wires here. So it seems that we have a brushless motor, okay, with 3 phases here. This part is maybe a microcontroller. So there is a conformal coating on that board, a soft one, a kind of silicone. For the test, I have connected the servo motor to this function generator in pulse mode. The frequency is set to 50 Hz. The width can be adjusted between 400 microseconds to 2.4 milliseconds. This is the range of the servo motor. I have also connected the DMM here to the feedback output. Currently, the pulse width is 1.5 milliseconds. You can see we have a voltage of 2.5 volts. And 600 microseconds, so this is the minimum pulse width. .4 milliseconds. This is the maximum range. Okay, there is a voltage of 0.1 volt. Okay, the maximum voltage is 4.6 volts approximately. Okay, the range is approximately 180 degrees. Approximately. It is possible also to change the resolution. I will change the pulse width with 10 microseconds increment. Okay, I will try to make a zoom. Okay, this is a step of 10 microseconds. I will change the step to 1 microsecond. It is difficult to see the variation. This is a complete schematic diagram of this servo motor. The power supply is on the top here. The reverse polarity protection is here. The power stage in the middle here. The microcontroller is here. The position sensor. The input stage, which is galvanically isolated from the rest of the circuit. So there is the motor here. Okay, the driver for the 6 MOSFETs. And we have here an analog output. The power supply input is here. The wire is the positive terminal. The black wire the negative one. You can see that the black wire is not connected directly to ground, but it is connected to the drain of this N-channel MOSFET. Startup, and there is a voltage drop due to the intrinsic diode here of the MOSFET. For the ground is at 0.4 volt, approximately above the black voltage here. But at the same time, the positive terminal here permits to saturate this transistor. So therefore the diode is short-circuited. Therefore there is a very small resistance between the ground and the black terminal here, a few milliohms. This capacitor permits to accelerate the conduction of the MOSFET. Therefore the energy dissipated on the intrinsic diode here is minimum. The purpose of this transistor is to have a protection against reverse polarity. If you suppose that you connect the positive voltage here and the negative on that point here, the body diode will be reversed biased, and the voltage of the source here is identical to the voltage of the gate, because there is the complete circuit between the ground here and the positive input here. So therefore the voltage between gate and source is 0 and the MOSFET is off. So this is the complete power supply of the board. The input voltage is here. Voltage should be between 12 volts approximately and 15 volts. Here is the first step down voltage regulator using this part XL7005. At that point there is a voltage of plus 10 volts. There is a linear regulator here, U4, which permits to have a voltage of 6 volts on that point. And there is a second voltage regulator here. The marking is BBV1. I don't put, and there is a voltage of 3.3 volts here. The power stage of the brushless motor is here. There are 6 N-channel MOSFETs, SE10070. The current can be controlled using this shunt resistor of 5 milliohms. The voltage is amplified with this differential amplifier. It uses an SGM8581. The output voltage is filtered and is fed to an analog input of the microcontroller. The motor is here. The stator is connected to the power stage. There are 3 Hall sensors inside the motor, which are connected to 3 inputs of the microcontroller here. MOSFETs are driven using this part. It's to drive 3 low side MOSFETs and 3 high side MOSFETs, an EG2134. The 6 inputs here are connected to 6 outputs of this microcontroller. The pulse width modulation input is here. Permits to drive this optocoupler TLP 3, C1. The output is fed to this strange arrangement, so I don't know exactly the purpose of these clamping diodes here, because I don't know also why the output is not connected directly to the two inputs here of the microcontroller. Position sensor is here for the feedback of the servo control. I think it is a kind of digital encoder. Okay, it is supplied with a voltage of 3.3 volts. Okay, and there are two outputs connected to the microcontroller. So here there is a circuit which permits to give a feedback output. The output here we should have a pulse width modulation signal. The signal is filtered using the second order low pass filter. So this permits to have a DC voltage at the output here. There is another filter. This permits to have actually a voltage which depends on the position